Lesson 9.1 is entitled Introduction to Waves. Lesson 9.1 has the following goals. 1. To define waves. Identify the types of mechanical waves. Goal number 2. To describe the characteristics of waves and solve problems that relate the frequency, period, wavelength, and speed of waves. What are waves? Both particles and waves carry energy, but there is an important difference in how they do this. Think of a ball as a particle. If you toss the ball to a friend, the ball moves from you to your friend and carries energy. However, if you and your friend hold the ends of a rope and you give your end a quick shake, the rope remains in your hand. Even though no matter is transferred, the rope still carries energy through the wave that you created. A wave is a disturbance that carries energy through matter or space. Waves transfer energy from one place to another, but they do not necessarily transfer any mass. Waves are disturbances which propagate or move through a medium. Waves can be viewed as a transfer of energy rather than the movement of a particle. Particles form the medium through which the waves propagate, but they are not the wave. Waves are classified into different types according to their natures. There are two major classifications of waves. We have the mechanical waves and electromagnetic waves. Mechanical waves are further classified into transverse waves and longitudinal waves, while electromagnetic waves are only transverse waves. Let us consider the mechanical waves. Mechanical waves are waves that require a material medium to travel. A medium is a substance through which a wave can travel. Example, water, people, air, or coiled wire. Mechanical waves cannot travel to a vacuum. Water waves, sound waves, and the waves that travel down a rope or spring are examples of mechanical waves. According to the direction of vibration, waves are classified into transverse wave and longitudinal waves. A wave in which the motions of the matter particles are perpendicular to the direction of propagation of the wave itself is called transverse wave. Longitudinal waves are waves in which the directions of the matter particles are in the same direction as the wave propagation. Let us now consider the characteristics of waves. A characteristic is how something is, how it behaves, appears, interacts, and so on. Let us consider the transverse wave for demonstration. The amplitude A is the maximum displacement of the medium from its equilibrium position. The wavelength lambda is the length of one cycle of the wave. The frequency F is the number of complete oscillations or vibrations made in 1 second, and the unit is hertz. The period is the time taken for one complete oscillation in seconds. It is related to frequency by the formula T equals 1 over F. The crest or peak is the highest point of a transverse wave. The trough is the lowest point on a transverse wave. The wave equation. The wave velocity, frequency, wavelength, and period are related by this equation called the wave equation. V equals F times lambda, or V equals lambda over T, where F is the frequency in hertz, lambda is the wavelength in meters, and T is the period in seconds. Let us do some examples now. Example number 1. Find the speed of a 20 Hz wave that has a wavelength of 5 meters. Solution. Here we are given the frequency, which is 20 Hz. The length of the wave or wavelength is 5 meters, and we are required to find the wave speed. Using the formula V equals F times lambda and substituting the values, we have V equals 100 meters per second. Example number 2. A wave has a speed of 50 meters per second. If its frequency is 100 Hz, what is the wavelength? Here we are given the speed of the wave is 50 meters per second, frequency is 100 Hz, and you are required to find the wavelength. So, from the formula V equals F times lambda, rearranging to solve for lambda, we have lambda equals V over F, and substituting the values, lambda equals 50 over 100 or 0.5 meter. Example number 3. Consider the following graph, then answer the questions that follow. First, we draw our equilibrium line. You have that one. Mark one cycle of the wave, starting at 0.75 meter. Where does the second cycle end? So starting at 0.75, here is the first cycle, then the second cycle, which ends at 2.75 meters. Next, you are required to find the number of complete cycles. So we can start from 0 to 1 is one cycle, then from 1 to 2 is another cycle, from 2 to 3 is another cycle, and from 3 to 4 is another cycle. Therefore, there are 4 cycles. Next, the wavelength. The wavelength is the length of one cycle, which is just 1 meter. Next is the amplitude. Amplitude is the highest point of the wave, which is 2 meters from the equilibrium line. If the frequency is 4 Hz, find the speed. So, from the formula V equals F lambda, substituting the values, the frequency is 4 Hz, the wavelength lambda is 1, therefore 4 times 1 is 4 meters per second. Example number 4. A piano string tuned to middle C vibrates with a frequency of 265 Hz. Assuming the speed of sound in air is 343 meters per second, find the wavelength of the sound waves produced by the string. Here we are given the frequency, 265 Hz. The speed of sound is 343 meters per second, and we are required to find the lambda. So, from the formula V equals F times lambda, rearranging to solve for lambda, we get lambda equals V over F. Substituting the values, this is 343 divided by 265 equals 1.29 meters. Example number 5. A tuning fork produces a sound with a frequency of 256 Hz and a wavelength in air of 1.35 meters. Letter A. What value does this give for the speed of sound in air? And letter B, what would be the wavelength of the same sound in water in which sound travels at 1,500 meters per second? So for letter A, we are required to find the speed. So from formula V equals F times lambda, substituting the values, we have 256 times 1.35 is 345.6 meters per second. For letter B, using the formula V equals F lambda, rearranging to solve for lambda, we have lambda equals V over F. Since V is 1,500 meters per second and the frequency is 286, substituting the values, the answer for lambda is 5.86 meters. Thanks for watching. Please do not forget to subscribe.